Here is the next example. In this example, we are finding the transfer function by using Mason's gain formula. So from the signal flow graph. So step 1, always find all the forward paths. So forward path is starting from input, reaching the output without going through any path more than once. Okay, so that's path 1. And path 2, I can go from here Z1, Z2, Z5 and C. So P2 equal to 1 Z1, Z2 instead of Z3, Z5 and Z4. Those are the only 2 forward paths I see. I don't see any forward paths. Now we'll find step 2, loops. How many loops are there? So let me see. Here is loop 1. You can clearly see that's a loop 1. Loop is nothing but starting and ending are same. Starting node and ending node is same. So minus Z2 H1. Okay, that's a loop 1. Loop 2, here I can see loop 2. That is my loop 2. Loop 2 equal to minus Z4 H2. Loop 3, let me show loop 3. Can I take this as loop 3? Okay, so loop 3 equal to Z1, Z2, Z3, Z4 and negative 1. So basically that is negative. The feedback path has -1. So if I multiply with negative, it's on negative. Are there any loops in this system? Okay, think about it. Review one more time. I can see one more loop. I mean, if you don't practice enough, for sure you're going to forget the 4th one. So here is the 4th loop. Let me use different color. Okay, green. Okay, so here is the 4th one. I can go over this and that. That's a 4th loop. So loop 4, L4 equal to Z1, Z2. So instead of Z3, it's a Z5 and Z4 negative. So -1. So that's loop 4. So we have 4 loops in this system. And now step 3, find delta. Oh, sorry. Step 3, 2 non-touching loops. 2 non-touching loops. So are there any loops which are not at all touching each other? They shouldn't touch at the node. They shouldn't touch the same path. So if you look at loop 1 and loop 2, okay, loop 1 is right here, loop 2 is right here. They both are not touching to each other either at the path at the node. So I can say loop 1 and loop 2, those 2 are 2 non-touching loops. Are there any other loops which are non-touching? No, every other loop is touching to each other. Then I mean, in the step 3 itself, find 3 non-touching loops. 3 non-touching loops. So loops which are not touching at the node or doesn't have any common path. So here I don't have any, so I'll take that as none. So that's step 3. Now step 4, find delta. Okay, step 4, find delta. Delta equal to 1 minus sum of loops, okay, plus sum of product of 2 non-touching loops. Product of two non-touching loops. Okay. Minus sum of product of three non-touching loops. So here I don't have any, I'll put none for time being. So sum of product of three non-touching loops. So we don't need to worry at this point because we don't have any three non-touching loops. What is sum of product of two non-touching loops? So basically what we're going to do here, I have two non-touching loops are L1 and L2. Say for example I end up with another loop Lx and Ly is also other two non-touching loops. I'm just labeling to give you some example. Okay, so what we're going to do, sum of product of two non-touching loops is nothing but L1 times L2 plus Lx times Ly. That's how you write. Okay, so here I don't have Lx and Ly in this example, so I can eliminate that. So all I'm going to write L1 times L2. So delta equal to 1 minus, okay, everything has minus in the loop, so minus G2H1 minus 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 minus. So I'm going to minus minus get cancel out. So I will end up with the plus 1 plus Z2H1 plus Z4H2 plus Z1, Z2, Z3, Z4 plus Z1, Z2, Z4, Z5. That is our, I mean, that's plus L1 times L2. So plus, what is L1 and L2? I have minus G2H1 minus G4H2. So if I cancel the, I mean, minus minus become positive. So Z2H4, Z2, Z4, H1, H2. That's our complete delta. Now we'll find we'll write down the Mason's formula. So transfer function equal to so how many forward paths are there? There are two forward paths. So P1 delta 1 plus P2 delta 2 over delta. So I have delta, I have P1 and P2. Now I need to find delta 1 and explain one more time. Let me explain one more time how to find delta 1. So to find delta 1, all you need to do, take delta, okay, remove any element in this delta which is touching path 1, either one of the path or any node. So look at 1, you have to have 1 there. I mean 1 is not there. So Z2H1, okay, Z2 is touching, so eliminate that. Z4H2, Z4 is touching, eliminate that. Z1, Z2, Z4, so Z1, Z2, Z3, Z4, eliminate that. Z1, Z2, eliminate that. Z2, Z4, eliminate that. Okay. Sometimes you will not have any element. So in path 1 you may not have all these elements, but still we may need to eliminate because maybe one of the node is touching that path. Okay, so that's how we'll find delta 1. Same thing with the delta 2. So path 2, I have path 2, this is my path 2. Okay, so eliminate any element which is touching that path. Okay, either touching at the node or touching any one of those paths. So we'll end up with delta 2 equal to 1. So the transfer function for this equal to P1, I have Z1, Z2, Z3, Z4 plus Z1, Z2, Z4, Z5 over delta 1, multiplied by delta 1, which is multiplied by 1 over delta is 1 plus Z2H1 plus Z4H2 plus Z1, Z2, Z3, Z4 plus Z1, Z2, Z4, Z5 plus Z2, Z4, H1, H2. Okay, this is our final transfer function. Okay, I will solve at least 2 or 3 more examples how to find the transfer function from the flow graph. Thank you.